everyone. Today we're going to talk about lesson 13, which is another way of solving quadratic equations using the quadratic formula. But first, here's a joke. How do you keep warm in a cold room? You go to the corner because it's always 90 degrees. So let's first revisit lesson 12 to solve this equation the way we did it in a previous lesson to see what the problem is. So we'll solve 2x squared plus 3x minus 6 equal to 0. And the way we learned, when the coefficient in the front is not 1, in this case it's 2, we can use the box method. So we'll put the 2x squared in the first box, and the last term, the negative 6, in the last box. And then we're going to look for two numbers that are going to multiply to be first times last, which is negative 12, and at the same time they add to the middle term, which is positive 3. So two same numbers have to do both things. So we can try, for example, negative 6 times 2, that's negative 12, of course, but then negative 6 plus 2 is going to be negative 4. That does not work. How about we could try positive 6 times negative 2, and you'll see pretty easily that that's going to give me positive 4 if you subtract, so that doesn't work as well. We can try maybe negative 3 times 4, that's negative 12, but then negative 3 plus 4 is going to be positive 1. Still doesn't work. And you could keep going, but the idea is you're never going to find two numbers that are going to do both things. And so that's where another strategy becomes really important. And this is in fact a pretty big one because it generalizes everything with solving quadratic equations. And you could actually use the quadratic equation to solve quadratic functions that can be done this way as well. But so when a quadratic equation can't be factored, you could still solve using the quadratic formula. And at first it looks kind of mean and intimidating, but once you start using it, you'll kind of see a structure to it. So the idea of the quadratic formula is you're still finding what the x values of a function are. So it's going to be x equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And the a, the b, the c, those are just the coefficients from the original equation. So we'll use this quadratic formula to solve this this quadratic equation we're going to solve using the quadratic formula. So let's do that for example 1. Just kind of fold the paper in so it's easier to show it on the screen. So let's start just by identifying what a, b, and c are. A, my leading coefficient is 2. B is 3. And then c is negative 6. Those are the coefficients from this quadratic equation. And then I'm going to write the quadratic formula. I'm almost going to kind of write it as a fill in the blank. So I'm going to write it as negative, put some parentheses where I'm going to put in the b value, plus or minus the square root, parenthesis squared, minus 4, parenthesis to show multiplication. So this is going to be the a coefficient and the c coefficient all over 2a. So looking at our reference, negative is part of the equation. So if b was minus, you would have put another negative there. In this case, the b is 3. So negative b, negative 3, plus or minus. The reason is square root. Consider both positive and negative answers. B squared, what's b in this one? 3, minus 4 times a times 2, that's a. My c coefficient is negative 6. and then everything all over, meaning everything gets divided by 2 times my a coefficient. So my a coefficient is 2. And so we're just going to simplify this in 2 steps. So we're going to simplify the stuff inside the parentheses. So we'll keep it as negative 3 plus or minus the square root. 3 squared, 3 times 3 is 9. Minus, now I have 4 times 2 times negative 6. So it's kind of like a three-way multiplication here. Negative 4 times 2 is negative 8. And negative 8 times negative 6 is positive 48. So in other words, I could always put into the calculator. So I have negative 4 times 2 times negative 6. Negative 4 times 2 times negative 6 is 48. So I'm going to put in plus 48 all over 2 times 2 is 4. And then we'll simplify this one more time. So negative 3 plus or minus the square root 9 plus 48. 9 plus 48 is 57. And then all over 4. And so that is the exact form of the answer. There's nothing we can do here to simplify it down. But what we could do is, if I say, well, where is this actually on the graph? It's a lot easier if we get this as a decimal, so we can actually visualize it. On the ACT, a lot of places they would prefer this form, but for us, it's going to be helpful to see where's this value on the graph. So let's put it in. Again, there's going to be 2 solutions because it's negative 3 plus and negative 3 minus. So my first solution I'm going to put in as negative 3 plus square root of 57. To make sure I'm doing the correct order of operations, I'm going to hit enter and then divide that by 4. So I get 1.137. I'm going to round that to 2 decimal places, so one of my solutions is going to be 1.14. So I would expect the graph to cross the x-axis at 1.14. And I would also expect it to cross at negative 3 minus the square root of 57. Again, hit enter to make sure my order of operations are done correctly. Divide that by 4. On my calculator, when I hit divide, it says answer, so it's just taking my previous thing. If you have a calculator that doesn't do that, I could just type in negative 10.5498 and divide by 4. Either way, I get negative 2.637, so I'm going to say negative 2.64. And so between those values, that's my exact form, and those are my approximate solutions. So if I was to look on a graph, I would expect the graph to cross at those 2 points. And I actually did plot this in Desmos to see where it crosses to kind of confirm that's correct. And so here's what it looks like. When I put it in, I got this graph, and one of the points it crosses at is negative 2.637. So I rounded to negative 2.64, so that looks good. And the other one was at 1.14. Looking at this value here, it's 1.137 again because of the rounding. This Desmos added an extra decimal, but you can see that that kind of confirms that our solution is correct. So one more example. So we'll do negative 3 minus x plus 8. This time it's equal to 2. In order to successfully solve this, that 2 has to be 0, so we just got to move that over to the side. First, let's subtract 2 and rewrite it as negative 3x squared minus x plus 8. Remember, we're subtracting 2 from both sides, so it's going to be plus 8 minus 2 is 6. Now it's equal to 0. Right, so since once you have 0 on the right side, now it's in the correct form in order to apply the quadratic formula. So let's proceed with that. So my A is -3. My A coefficient is -3. My B, in this case, it just says -x. One of the common mistakes that I've been seeing over the last couple of years is if it doesn't have a coefficient in the front, students put x or -x. But in this case, if it does have a variable but no coefficient, we're going to take 1, or in this case, since it's -x, -1, and the C coefficient is 6. So again, I'll use the structure where I'm going to lay the quadratic formula out and then throw those numbers in. So opposite of B, my B value is going to go in there, plus or minus the square root, B squared minus 4 times AC all over 2A. So negative B squared, -1. So that's kind of one thing I mentioned earlier, is the minus is there as part of the equation, but in this case I have -1 as well. So in the next step, that negative and negative is going to make that B into a positive. Plus or minus the square root of B squared. So -1 squared minus 4 times A. A is -3 times C, +6, all over 2A, all over 2 times -3. So let's simplify that down. -1 is going to be 1 plus or minus the square root. Another very common mistake is you're taking -1 squared. It's kind of like saying -1 times -1. It's going to be +1. And that first A squared is always going to be positive. Sometimes I have people putting in something like -1 squared, and that does give you -1. But what you should be putting in is -1 in parentheses and then squared. So that's always going to be a +1 minus, but then since I have minus and minus, it's going to end up being plus -4 times -3 times 6. Let's put that in the calculator. -4 times -3 times 6, 72. So plus 72 all over 2 times -3 is -6. So that gives me 1 plus or minus the square root. 1 plus 72 is 73 over -6. And that's my exact form of the answer. Oftentimes, if it was multiple choice, you'd see the negative move up to the top, and sometimes they would put it, instead of in front of the -6, they put it over here, is often done with fractions, but we'll leave it in this form and then get the decimal approximation of this. So let's break it up into 2 parts. And in the first part we're going to do, let's clear my calculator, so we're going to go 1 plus square root of 73, enter, and then divide that answer by -6. So one of my solutions is going to be -1.59. And then the other one is going to be 1 minus square root of 73. Enter, divide that by -6. And it's going to be 1.257, so I'm going to say 1.26. So exact form, and these are my 2 decimal forms, so I would expect the parabola to be crossing at these 2 points. I don't have this one graphed in Desmos, but if I did put this, actually this is really all I need to check. If I did put this into Desmos and looked at where the graph crossed, I should see this as a very easy way to just confirm that my answer is correct. Alright, so I'm going to stop here. Hopefully this is enough to kind of get you started. If you guys have any questions, feel free to hop on to Zoom or send me a message. Thank you.